morning, children. Today we are going to start with the circle chapter of mathematics 2. Already in the last video we have completed the first session. So now the next section is circle, arc of a circle. So before that, let's go through some revision of this. This is the circle, you know. This is the diameter. This is the center of the circle. This is the chord, and this blue line shows the tangent of the circle. So tangent of the circle, and this is the point of contact of the circle, that is tangent. So point of tangency. And what is this? This is the secant of the circle. So here also one secant we have done. When this chord will extend, that will be a secant. So this is center of the circle. Then come to arc length. So what is arc and what are the types of arc that we are going to learn in this session. So here, arc of a circle, you can see the diagram of the circle. Here radius you can see. So this portion which is blue colored one, this portion, this blue and purple one, this the portion of arc of length. So let's move to the arc of circle. A secant divides a circle into two parts. Any one of these two parts and the common points of the circle and the secant constitute an arc of the circle. So if you can see, this is arc of the length. So this arc means it is dividing. A chord can divide. It is dividing into two parts. So this small area, the small arc, which will be defined as minor arc, and this the larger part of the area, the larger arc of the circle will be major arc. So here you see the definition. If the center of a circle is on one side of the secant, then the arc on the side of the center is called major arc. So the arc which is on the other side of the central angle, that is called minor arc. So you just see the central angle. This is the angle formed by the center of the circle, that is P here. So here this is the central angle. This angle indicates the central angle. So it is included the arc AB. So this is minor arc. And which is this arc is ACB is the arc of major arc. So it is clear, minor arc, major arc and central angle. So see some parts of the circle. Already we have learned about this. Only this is the few revision that you can understand better this concept. So this is the radius, this is the sector, this is segment, this arc, this is the diagram, this is the circumference, diameter, chord, and this is the tangent. So move to the next session, that is congruence of arc. So congruence of arc, two arcs are congruent if their measures and radii are equal. You can see these concentric circles are there where the two radius and the measures are equal, then they are called congruence of arcs. So here property of sum of measure of arc, that is what property means. If I'll ask that measure of arc ABC, so A, B, C, this measure of arc if I'll find, so this is the addition of ABC plus arc CDE equals to measure of arc ACE. So ACE, so ACE is the measure of arc of addition of measure of arc ABC plus measure of arc CDE. So some few notes. Two arcs of the same circle are adjacent. If they intersect at exactly one point, you can add the measure of adjacent area, like it's a postulate addition postulate, what we have learned in the 9th standard. So the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. So this only it is mentioned here. We can write arc or we can put this arc like structure on this. So it's a symbol for arc. So measure of arc ABC will be equals to measure of arc AB plus measure of arc BC. You can see that A, B, C. So this is measure of arc. So measure of arc AB plus measure of arc BC. Now come to the theorem. So the first theorem that we can see, that theorem corresponding arcs of congruent chords of a circle or congruent circles are congruent. So here, what is this? Here, what is given? Here given that corresponding arcs of congruent chords. So corresponding arcs of congruent chords, here given is O is the center, here P is the center we have taken, and chords, both chords are congruent. That means here both chords are given congruent. So you can see that AB is congruent to CD. So this is the chord. So it is given AB is congruent to CD. So here, and AB and DC are in the OP. So we want to prove what? What to prove? AB arc, that is arc, measure of arc AB is congruent to measure of arc DC. So here PA, PB, PC and PD are all radii. Radii of the circle, that means they all are congruent. If they all are congruent, that means arc, this line segment AB is congruent to segment DC, because it is given. Then by SS postulate, that means by SS test, we can say that these two triangles are congruent, because all these are radius. PD is radius, PC is radius, AP is radius and PB is radius. So all are by SSS test, these two triangles are congruent. If these two triangles are congruent, that means because corresponding parts of congruent triangles are congruent, then AB, segment AB equals to segment DC by the definition of congruent, that is arc AB is congruent to arc DC, hence proved. Now the second theorem, that is the chord corresponding to congruent arcs of a circle are congruent. So here you can see, that is the given that here AB segment and DC segment AB and segment DC act in the OP. Yes, segment CD and segment AB. So we have to prove that arc AB is congruent. Segment AB is congruent to DC, where AB arc is congruent to arc DC is given. So we will start with the proof which is given. So if it is given that arc of both is congruent, that means their measure of angle will be equal. That is only it is written. So measure of angle is equal, and the radii of these two, AP is congruent to PD and PB is congruent to PC. That means by SAS theorem, by SAS test, these two triangles will be congruent. If these two triangles are congruent by SAS, then corresponding parts of congruent of chords, arcs of a circle will be congruent. So hence it is proved. It is there in your textbook, page number 61. So just go through the textbook and listen the explanation carefully. Hope you must have understood.